Assalamualaikum students. Students, in this recorded lecture, I am going to cover group 2, but not the whole group 2 of A2. In group 2, there are 3 topics. The first topic is regarding observations. Like in the system, in the past paper, in Cambridge, when they ask questions, sometime they're about observation, like they focus on the observation of the group 2 element, how they react, dissolve, gases form, flame colors, the color of the group 2 element and their compounds and their solubilities, right? And second is thermal stability of carbonates, and third is solubility of sulfates and hydroxide. So I'm starting with the observation, which is a very small topic, but if you know all these, you will be more clear that from which background or from which topic the Cambridge is asking this question. Like the point is not this that you won't be able to do it. Sometimes you people do it because you have the prior knowledge of O levels and of AS. But once you do it in a systematic way, this make your topic much easy. The handling of your paper much easy. It boosts your confidence. Like you know everything and you're just performing, you're just writing the answers. So to explain this, I'm going to share the screen, but you know that when I share the screen, you people are supposed to share, like, and subscribe the channel. Okay, let me share. 3, 2, and 1. Yes. And come to notability. I'm writing group 2. Okay. Group here. Group 2. This. Look, in this group 2, the first thing is you must know that the group 2 element, they become more reactive down the group. Why? Because their size increase, because the number of shells are more, the size is getting larger, the nuclear attraction is less, the ionization energy lower, and they lose electron more readily. They are becoming more reactive. They are becoming stronger, reducing agents. Second, all the group 2 elements are silver colored. They're all silver colored, and their compounds, beryllium oxide, calcium carbonate, the rubidium sulfate. Rubidium is group 1, sorry. Barium sulfate, like all the group 2 elements are silver colored and their compounds are white solid. Flame colors. Beryllium, bright white flame. Magnesium, bright white flame. Red flame, green flame, right? You must know the flame color and then the solubilities. You must know that all the nitrate, chloride, bromide, iodide are soluble, but carbonates are insoluble. And hydroxide of group 2 and sulfate are opposite. Hydroxide, lower are more soluble. Sulfate, lower are less, upper are more soluble. Their solubilities are opposite. Their delta H solution becoming exo, their delta H solution becoming endo. This is fully explained in my next lecture. But right now, I'm going to explain what? Thermal stability of group 2 carbonates and nitrates. What we are going to do? Down the group, the thermal stability increase. Down the group, they are becoming more stable down the group. The lower need more heat to decompose. The upper need less heat. What? Both the carbonates and the nitrate. Why? What is the reason? I'm going to explain this on separate page, as you know that how I do this. Look, for explanation, I use separate page, and the notes are given. They are available on my website, Chemistry by Zeenat, along with topical past papers. So after doing this, you have to do, you will use the website for the notes and topical past papers, right? Now, look, if I'm explaining thermal stability of carbonates, look, you take a carbonate, any carbonate of group 2. The group 2 elements have how much charge? Plus 2. The carbonate has how much charge? Minus 2. So the formula is what? M carbonate. If you are, this is white solid, you know that this is white solid. This is group 2 carbonate. So you are heating this strongly. When you are heating, it will break. The carbon dioxide will go out. And what will left? The metal oxide left, white solid remains. In one of the past paper, they have asked, what is your observation when you decompose group 2 carbonate? What is your observation? You are heating a white solid, and even after decomposition, there is a white solid. You can't see carbon dioxide. You can see carbon dioxide when it is out of liquid, aqueous medium, liquid medium. You will see bubbles. But you can't see carbon dioxide coming out of a solid. Can you see carbon dioxide coming out of my mouth? No. But yes, if I'm swimming, there would be bubbles. Right? So the carbon dioxide, you can't see. So what is your observation? White solid remains is the only observation. So if you are breaking the metal carbonate, which is white solid, into metal oxide, white solid, and carbon dioxide. The upper need low temperature, the lower need high temperature. What is the reason? Now, how is the carbonate? The carbonate is this way. This is C double bond O, like carboxylic acid ion. This is carboxylic acid. If I remove the H, it becomes negative. This is CO. So if I put another O, this is what? CO3 minus 2. This is what? CO3 minus 2 is carbonate. Right? Now, you know what is happening? This is carbonate. I'm writing the carbonate twice. These are two carbonates. This carbonate is with beryllium, and this carbonate is with barium. And this need low temperature. This need high temperature. This shows that this is more stable. Now, where is the difference? Is the carbonate different down the group? Just think. Is there any difference in the carbonate? No. The carbonates are 100% same. What is the difference? In the cation. And what in the cation? This is small and this is what? Large. Look. Its size is large and its size is small. So down the group, the first difference is what? The size of the cation increase. Now, this is smaller cation. This smaller cation have more ability to attract the electron because, what I explained this to you in energetics in the first chapter. Which type of ions attract more, repel more, all the electrostatic forces? Which type of ion? The ions which are small with high charge, small with high charge, positive or negative, whatever. Ions with small size and high charge, they attract or repel more. Here, what is happening? They are attracting. बेरिलियम किसको अट्रैक्ट कर रहा है? ऑक्सीजन को. ऑक्सीजन को भी नहीं, इलेक्ट्रॉन्स को. Beryllium attract the electron of what? Oxygen. Barium attract the electron of oxygen. Which one will attract more? Beryllium. This attract the electron more. Now, when beryllium attract the electron of this toward this on side, what the oxygen will do? It will attract electron from this carbon. Huh? Like this. See? If beryllium attract the electron more, oxygen will in turn attract electrons from the carbon-oxygen bond. The electrons are no longer in between. They are no longer in between. The electron are close to oxygen. Huh? The electrons are close to oxygen. The electron cloud is no longer symmetrically distributed. The electron cloud is toward oxygen, polarized, distorted. When the electron cloud is distorted, it's kind of खिंचा हुआ bond है, खिंचा हुआ. There's tension inside it. This tension is caused by this beryllium because it is attracting electron. If beryllium is attracting electron of oxygen, oxygen will take electron from the carbon. The whole drift is toward the beryllium. This bond will break more readily because it's already tense, kind of tense situation. Huh? So I want to use red for this. So this break at low temperatures. When it will break, what will form? See, beryllium oxide plus carbon dioxide. Now, look, barium attract less strongly because its size is large. This bond is less polarized. So what I'm supposed to say? I will say that down the group size of cation increase, the polarizing power of the cation decrease. The cation that is larger in size polarize the carbonate less. This carbonate is less polarized. So if it is less polarized, high temperature is needed. Barium oxide and carbon dioxide will form at high temperature. And exactly same situation is in nitrates. How? First thing, metal of group 2 plus 2, the nitrate is minus. So what is the formula? MnO3 twice white solid. So if you are heating group 2 nitrate, which is white solid, it will decompose into metal oxide plus 2NO2 brown gas plus half O2 colorless gas. This is white solid remains, brown gas, colorless gas. This is brown gas. And what are you supposed to write? This is white solid. White solid remains and brown gas You can't see oxygen, it's colorless. Now, how the decomposition occurs? You can see it. Now, when the decomposition occurs, look, carbonate is this way. But nitrate is N double bond O. One is dative and one is O negative. Nitrogen is an element of group 5. 1, 2, 3, 4, 5. Oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this electron is from outer side, therefore it's minus. Suppose if I put the two arrows here, the crosses, right? Like this. Now, 1, 2, 3, 4, 5, 6, 7. And oxygen has 8, but what about nitrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nitrogen is the element of period 2. In nitrogen, the last shell is what? Second shell. Second shell has a capacity of 8, not 10. So nitrogen will make a double, a dative, and a negative. Right? So if there are nitrate, this is beryllium. And this is for barium. Now, which one need low temperature, which one need high temperature? You know this? Low temperature, less stable. High temperature, more stable. More stable. Why? Because down the group, there is no change in the nitrate, but the size of cation increase, polarizing power decrease. Now, beryllium attract the electron of the oxygen more, polarizes the NO bond, polarizes the nitrate more. So need less temperature to break. Attraction less. Less attraction. Less polarization, distortion. And high temperatures needed, and it will make what? Beryllium oxide, 2NO2, brown gas, and half O2, and barium oxide, 2NO2 plus half O2. So, एक दफा देख लिया आप. There is no difference. There is no difference in the nitrate. There is no difference in what? The carbonate. Where is the difference? Size of cation increase. Size of cation increase. The polarizing power of the cation in decrease. The nitrate or the carbonate with a larger cation is less polarized. So therefore it needs high temperature. They're getting more stable. If I show the notes, what I've written, down the group's thermal stability of group 2 nitrogen and carbonate increase. They become more stable down the group. As the size of the cation increase, its polarizing power decrease. The lower cation, that is larger in the size, polarizes, distort the carbonate, the nitrate less. Therefore, such carbonate nitrate need more heat and they are more stable to heat. right? And this is the whole explanation why solid remains, and the why solid remain is the only observation. And this is for carbonate, and then this is for, you can see this on the website, right? And in the next lecture, I'm going to explain what solubility of group 2 sulfate, right? So I'm going to, like, I did the whole energetics. Listen, students, I've done the whole energetics in 4 lectures, and then in 2 lectures, group 2, uh, carbonate, the whole group 2. And now I think I'm going to finish the entropy, the spontaneity, the delta G in 3 lecture, inshallah, inshallah. And I hope you understand. Now you are supposed to like, subscribe, and share my channel. Sufficient for today. Allah Hafiz.